Fleming's left-hand rule. It was originated by John Ambrose Fleming in the late 19th century. So let us know about this rule. So the left-hand rule is whenever a current carrying conductor is placed inside a magnetic field, a force acts on the conductor in a direction perpendicular to both the direction of the current and the magnetic field. So basically what this law states, whenever a current carrying conductor is placed in a magnetic field, the conductor experiences a force. According to Fleming's left-hand rule, if the thumb, forefinger and middle finger of left hand are stretched perpendicular to each other as shown in the image, and if forefinger represents the direction of magnetic field, the middle finger represents the direction of current, and then the thumb represents the direction of the force. So that force will be perpendicular to both the direction of the current and the magnetic field. So this is our Fleming's left hand rule. Now, let us know about the uses of Fleming's left-hand rule in various equipments. So, first of all, you have electric motor. Electric motor is a very good example of Fleming's left-hand rule. So, here what happens? When a rectangular coil carrying current is placed in a magnetic field, a torque acts on the coil which rotates it continuously. When the coil rotates, the shaft attached to it also rotates, and thus it is able to do mechanical work. So this is the science behind our electric motors. Now let us go through all the parts of the electric motors. First of all, you have armature, then commutator, then brushes. So a DC motor consists of a rectangular coil made of the insulated copper wire wound on a soft iron core. This coil is mounted on an axle and is placed between the cylindrical concave poles of the magnet. So here in the image, this is your armature. Look at the pointer. So this is your armature, and it is the coil which is mounted on the axle and is placed between the cylindrical concave poles of a magnet. So this is your armature. Then comes your commutator. A commutator is used to reverse the direction of the current. Commutator is a copper ring split into two parts, C1 and C2. The split rings are insulated from each other and mounted on the axle of the motor. The two ends of the coil are soldered to these rings. They rotate along with the coil. Commutator rings are connected to a battery. The wires from the battery are not connected to the rings, but the brushes are connected to it, which are in contact with the rings. In short, a split ring wrapping around the axle. So here you can see the extended view of the commutator. Here what happens? A split ring. This is your split ring. So look at the image. This is your split ring that is wrapping around the axle. This is your axle. And the commutator makes physical contact with the brushes which connect to opposite poles of a power source. So here these brushes are connected to the different power sources to deliver positive and negative charges to the commutator. So now you got clear about the commutators. Then your brushes. Two small strips of carbon known as brushes press slightly against the two split rings, and the split rings rotate between the brushes. The carbon brushes are connected to DC source. So here you can clearly see in the image that the blue portion is the commutator and the grey portion is your brushes. So now you are clear about the electric motors. Then you will know about the working of a DC motor. Now, how the DC motor works. So here in the image we can see the DC motor. When the coil is powered, a magnetic field is generated around the armature. The left side of the armature is pushed away from the left magnet and drawn towards the right, causing rotation. Then when the coil turns through 90 degree, the brushes lose contact with the commutator and the current stops flowing through the coil. However, the coil keeps turning because of its own momentum. So here the coil keeps turning because it has its own momentum. Now, when the coil turns through 180 degree, the sides get interchanged. As a result, the commutator ring C1 is now in contact with brush B2 and the commutator ring C2 is in contact with the brush B1. Therefore, the current continues to flow in the same direction. So, this is how the DC motor works. You can increase the efficiency of the DC motor by increasing the number of turns in the coil and also by increasing the strength of the flowing current, and also you can increase the efficiency of the DC motor by increasing the area of cross section of the coil. So guys, we have just studied about Fleming's left-hand rule and its uses in an electric motor. So hope you like this video a lot. Thank you very much.